Okay, let's take a look, class, now at our first example here. Let's suppose that you could have $1,000 today, or you could get it 1 year from now. Do you care? Hopefully the answer is yes, I want it now. Okay, situation one, you'd say, I'll take it now, and let's suppose I can invest it, and we'll just make up a number here. We'll say 6%. Well, at 6%, you do principal times interest times time, right? $1,000 times 0.06, or move this over, 1% would be $10, so 6% would be $60. Add it to the principal, you'd get $1,060 1 year later. Okay, if you invested your 1,000, that's what you'd make, $60 in interest plus the principal back. Okay, so a year from now it'd be worth 1,060. All right, let's suppose that you were to get $1,000 a year from today. That's not as good right there. You can see it. Okay, so let's figure out what's the present value today of that $1,000 that I'll receive a year from now. Now, here's your first foray into this concept. What's the value today of $1,000 a year from now? A lot of people might say, well, it's $1,000. Silly question. It's not true. Okay, the value right now of getting $1,000 is less than $1,000. Okay, so here's what's going to happen. Okay, we're going to take a look at this. We're going to set up a problem called present value. In other words, we're bringing that $1,000 payment a year from now, we're bringing it back a year to today. And this process is called discounting. And so we're going to use this 6% interest rate. That's what the going rate is for investments right now. And when they give it to you in the problem, that's how you use it. But basically, it says that this factor, you're going to multiply this $1,000 times a factor. We're going to show you where to get that from a table. Okay, this factor must account for interest and time. Okay, and how do you find that factor? Well, you go to your appendix in the back of your book in B1. There are tables there. Okay, so you've got to find those tables and you've got to look at that present value of $1. What it's really saying to you is that here is the value down the road of $1 if my interest rates were whatever they say they are. Okay, so I'm on page B10 of your book, for most of your books. I hope the page numbers are correct for everybody, but the back of B10, you'll see four tables, B1 through B4. The very top one says present value of 1. Really, it's present value of $1. Okay, and somebody's made all these calculations for you. You don't have to worry about it. But if I said n equals 1, n is the number of periods. You can see that along the left side of the column. In fact, I think I'll show you here. Okay, here's what one looks like on the web. Number of years or number of periods would be a better term than this one I just pulled off the web. And we said 6%. So if you take the first row and go across and say 6%, 1 year, 0.943. There's my value right there, 943. Same thing as in the back of your book. It has more digits. Back of your book says 0.9434, but it doesn't matter. That's close enough. Okay, so now we're going to go back here. All right, and when we do this, okay, we're going to get back to this, and it's going to say 0.9434. I plug it in, and my math is easy here because it's just 3 zeros. It's worth 943. Excuse me. What this means is that the value today of getting $1,000 a year from now is actually $943, given that interest rates are 6%. Now you got to think about that. Okay, does that seem right? It is right. Okay, but you've got to kind of grasp that. What this means is I am absolutely indifferent as an investor. I don't care if you give me 943 right now and I can go and invest it at 6%, or if I just waited a year and you gave me $1,000 a year from now. Doesn't matter. It's equivalent. It's the same thing. Okay, so let's test it, right? First of all, take 943 that we got today. That's the value of it today. And if we invested at 6% for a year, well, let's do it. 943 times 0.06 times 1. I did the math for you. $57, add it to 943. There you go. It's worth $1,000 a year from now. It works out. It has to. So this is simple math. As long as you can multiply 6% times 1 year times the principal. Okay, if I got 943 today, I invested it at the going rate, it would earn me $57 interest and it'd be worth $1,000 a year from now anyway. So $1,000 a year from now, 943 today, same thing. So when you bring back money from the future, it's worth less dollars today because you have to wait to get it. If you had 943 today, I can invest it and it'll grow to be $1,000. That's why $1,000 a year from now is actually worth 943 today. Okay, if interest rates are higher, that means I can do more with it right now. Therefore, you have to grasp this concept. If interest rates were higher, suppose they were double that, suppose they were 12%, I could make more interest if I had the money now. So $1,000 a year from now, if interest rates were 12%, would be worth more or less today than 943. The answer is less, because I could take 920 or whatever it would be. I'd invested at 12%, and it would work its way back up to $1,000 at higher interest rates. So when rates are high, waiting to get money in the future is even more punitive. If rates are low, let's suppose rates were zero. Well, yeah, $1,000 a year from now, same as $1,000 now, because rates are zero. But anyway, you've got to grasp that concept. $943 today, when interest rates are 6%, is worth the same as getting $1,000 a year from now. Okay. I feel like I've beat that to death, but you really got to grasp that. Okay, here's another example. Suppose you plan to sell a small business 5 years from now, and I know I'm going to get 10 grand for it. What's the present value of $10,000 if I can get 8% interest? Oh, compounded quarterly. What does that do for me? Oh, that's different. Okay, first of all, got to find the right interest rate. I'm going to take 8%, divided by 4 quarters, that's 2% per quarter. Everyone got that? 8% per year. If it's compounded quarterly, I got to get a quarterly interest rate. So 8 divided by 4 is 2%. Okay, first of all, number of periods of interest. I divided this top one by 4, but if I got 5 years and it's compounded quarterly, there's 4 quarters in a year, there's actually going to be 20 periods. Remember, n equals periods, not necessarily years. So that's how that works. Now I'm going to go to this formula. Actually, I'll just use the table. Again, it's going to be B1. All right. So I simply go present value equals the principal times some factor. I go look it up. Notice that I is going to be 2. It was 8 divided by 4. N is going to be 20. There's 20 quarters in 5 years. All right. So now I've got to go to B1. Why don't you guys do that? Go to B1. Look at 2%. Look at N equals 20. And hopefully you'll see the same number I see. Okay. I'm going to check out of here and go to my table here on the web. Okay. 20, this one says number of years. That's incorrect. It should be number of periods. So if I go to 20 and I look at 2%, I get 0.673. Your book says 0.6730. So this one is exact. Okay, so we're right there. All right, so what this means is if I simply plug in 0.6730 times the $10,000 I'm going to get 5 years from now, okay, 10 grand times 0.6730, it's worth $6,730. Think about what this means. If I were to get $6,730 today, that's exactly the same as waiting 5 years at 8% compounded quarterly to get 10 grand 5 years from now. That's a big difference. Look at that. It's like $33 or $3,270 difference. That's a big difference. However, if I could take this money right now, invest it at 8% interest compounded quarterly, it would grow to be equal to $10,000. So this is the same. I'll take $6,730 today, or I'll take 10 grand 5 years from now. Doesn't matter. Okay. Now let's take a look here. We're going to do a quick sample problem here. So let me go to this slide here. Suppose that it was not compounded quarterly. Suppose it was only compounded annually. What if it was annual, not quarterly? Okay, it says solve with a neighbor. Well, you don't have a neighbor probably. You're doing this alone. Okay, present value is equal to the principal times the factor from the table. But this time, if there's no compounding, within a period less than a year anyway, I'm going to go I equals 8, N equals 5. Remember, it's 8%. No compounding this time. 5 years. Okay, and I'll just go $10,000. I go to my table, look for I equals 8, N equals 5. Here we go. I equals 8. I'm sorry. Yeah, I equals 8 is over here. N equals 5, and I'd be right there. Make sure you get them right. The number of years was 5. This time they are years, not quarters. Interest rate is 8.681. Okay, so if I come back here, like a 0.681, your book had a little bit more detail, 0.6806. It's worth 6806. Well, wait a minute. Wasn't it 6730 a minute ago? So here's the deal. When it compounds quarterly, you make more interest if you're the investor. Therefore, this is correct. 6730 would grow to be $10,000 over 5 years if it was compounded quarterly. 6806 would grow to be $10,000 if it was 8% per year and no quarterly compounding. This one should be higher. Okay, so when you compound, you make more interest. It's effectively a higher interest rate because it's 2% 4 times a year. It's actually, if you do that math, it actually turns out to be more than 8%. So 2% times 2% times 2%, you get a little exponential growth there. So this is correct answer, okay? So the interest that compounds is favorable to the investor, so it's more punitive to wait 5 years than if there was no compounding, like in this example, okay? You don't need to understand this subtle detail here between that page and this page to really grasp the rest of the chapter. We hope that that at least makes it interesting to you. Okay, hope that's enough for you. We'll move on with the next video in a minute.